Now that you know first-order differential equations, and I've shown you examples of how air resistance would work, I'll explain how to actually solve a problem in the way I've shown. In this problem, there's a boat traveling to the right with no force aiding it, but one opposing, the force due to friction. The boat, having mass of 1,000 kilograms and traveling at a speed of 90 kilometers per hour, or 25 meters per second, uses a force of friction equal to velocity multiplied by 70. Very similar to our force equation used before, where force is proportional to a constant k value. The problem asks us to find the time it takes for the boat to slow down to half of its initial speed. To begin with, we look at the system and realize that the sum of forces is equal to just negative force of friction, which also equals mass times acceleration. We can simplify to mass times acceleration equals negative force of friction. Now, we realize once again that acceleration is the derivative of velocity with respect to time. Separate both variables to each side, and now we integrate, finding ourselves with another natural log function. Like always, we use our natural log trick. E to the ln of any function is equal to the function itself, so we are left with v alone equal to some constant times our exponent. Now, like I showed before, to find a, we plug in our known values, which in this case are the initial values of v and t. We find that a equals 25, and plug that back into our equation, giving us our first order differential solved. V of t equal to a function with only one variable, t. To find the time we want, we must now plug in our other values we know, such as the final velocity, and then we start simplifying and solving. 1/2 equals e to the negative 0.07 t. And now to get rid of base e, we simplify it to its natural log format, and use a calculator to solve, giving us 9.9 equals t, the time it takes to reach half of the initial velocity when the opposing force is v proportional to 70, the mass of the 1,000 kilograms.